Hi everyone, welcome to my channel. My name is Fikret. This video continues video tutorials dedicated to learning Microsoft Fabric. In the last video, we started exploring Spark structure streaming in Microsoft Fabric. So we learned creating streaming pipeline from different sources, and we learned controlling Spark streaming pipelines. So we also had a good discussion around key structure streaming concepts. So if you haven't had a chance to watch that video, I would recommend to pause this video and take a look. Also, quick reminder, if you are new to the channel, please subscribe so that you could always get latest of my videos. Here's a quick preview of what I'm going to cover today. We'll start with transformation discussion, and I will first demonstrate relatively simple transformations on how to add calculated columns and filters. Then we'll move on to aggregations. So first I will show how to apply simple aggregations. Then I'll show how to apply windowed aggregations, which are time-based aggregations. Then we'll discuss late arriving data. Any streaming pipeline, in my view, should allocate for late arriving data, and I'll explain how to handle that in Spark notebooks. Next, we're going to move to joins transformations. We will first discuss how to join streaming data frame against static data frame. Then we'll take a look at joining of two streaming data frames, and we'll talk about how to handle late arriving data. Next, we're going to talk about trigger types. First, we'll consider duration-based triggers. By default, if you don't specify trigger types, Spark Streaming will use default triggering length. However, there are ways to control this behavior. And then we'll talk about one-time execution, which is more suited to batch type of workloads. Then we'll take a look at forEachBatch functions, which allows you to overcome limitations of Spark streaming. So not all Spark transformations are available for streaming data frames, and forEachBatch functions allow to address this issue. Let's get started. All right, I am in Microsoft Fabric and I navigated to the Lakehouse called Bronze. If you don't have it, please go ahead and create empty Lakehouse. And all the code necessary for this demo will be contained within this PySparks notebook, which I'm going to share in the description of this video. The data for this demo will come from Azure Event Hubs. The first few cells within this notebook takes care of connecting to Event Hubs. To connect to Event Hubs, you have to create access policies and then take connection strings from these access policies. So the few cells that you will find at the beginning of this notebook takes care of that. And if you don't know how to obtain these connection strings and how to create access policies, please watch my latest video, Introduction to Streaming, where I explain this in detail. I already ran that part of the notebook, and I will walk you through the rest of the notebook. My next cell takes care of important necessary libraries. The few libraries that will be needed down the road are the Event Hub library, then MS Spark Utils libraries, which is good to handle certain folder operations. Then we'll often use SQL functions library, which is part of PySparks. And finally, we'll use SQL types to be able to parse certain JSON information. So let me run this. And then my next cell reads from Event Hubs and write into the Lakehouse. This I am using two APIs, read stream and the write stream for that purpose. So here's my read stream, and this is my write stream. Read stream reads from event hubs. It provides format here, and then it uses configuration variables that you will find at the beginning of this notebook, and the result is assigned to this data frame. Then my next command takes this data frame and applies light transformations. I mentioned that when writing the bronze, it's good practice to not to change the data too much, so to just satisfy with minimal transformations. So here I am just converting data type. So with this transformation, I convert data type for body column from binary to string. Data coming from event hubs is usually contained within body field, and it's in binary. So that's and we need to have this conversion so that we could have the further parsing of that. The next part of my command contains necessary constructions for write stream. So I provide query name here, and then I say my destination format is going to be delta. I provide checkpoint location and the path for this table. So all of this will come from variables at the top, and I say my write mode, output mode is going to be append, which is a typical when you are dealing with detailed data. So we'll talk about other write mode down the road when we discuss aggregations. And then results are assigned to streaming handle, which we'll be using for managing this stream as well as monitoring it. So let me run this. Okay, and then if I run the next cell, just remind you what these commands do. So basically I am using isActive property and the status property from stream handle to understand what's the status of my stream, which you will find here. So right now the stream is active, which we will see here, and then it's waiting for data. And then recent progress field will provide latest information. So I ran the stream earlier, that's why you will see some recent progress here. Okay, so now that our stream is up and running, let me navigate to Event Hub and explain how to generate the data. So this is my Event Hub. I'm gonna go to Generate Data tab, and from here I will select Vehicle Toll Boot Data. So this data represents vehicle traffic data passing through toll booths. So this is in JSON format, it's nested information. So here the important fields that we'll be working with are entry time, which represents event timestamp. Then we have car information, and then we have license plate information, which can be used as a primary identifier for this row. So I'm going to provide 100 sample and click send. So it sent 5,000 events, and I'll do it multiple times so that we have enough information. Okay, now I'm going to navigate back to my notebook and see how my stream is doing. So as you can see, my stream is currently processing new data, and it will show you status of the last few processing. So the streaming is usually very fast, and you'll find that that few thousand events that we have generated is being consumed within the seconds. So let me show you data. So this is the original data coming within the body field. As you can see, it's binary. It's not meaningful, but the fields that we have converted, it's in JSON format or dictionary, so you can see body as string field. Okay, now that we ingested data in bronze table, let's talk about some relatively simple transformations. Some of the transformations that you will see with streaming, they are very similar to batching transformations that we learned in past. So let me navigate to the next cell. So here I am creating data types to be able to parse JSON, and then result is assigned to this variable. So my next command reads from this bronze table, applies transformations, and writes in another table called car traffic silver. Here, once I read from this table, I use from JSON function, which is native Spark SQL function, to parse this data, and I provide schema that we created earlier. Then we use select transformation to bring to extract all the fields located on the events parse field. So events parse is generated here, and then from there I extract all the subfields. So this is star notation, allows us to easily extract all the fields. And then my next command extract all the fields under the car model. So basically, first I mention that first I bring star, which means that all the fields from the previous output, and then I say bring me all the subfields under the car model field. Next, I am applying filter here to limit the data to certain states, and then I drop this column, car model filter, car model column, because we no longer need this top level field. And then the rest is just to write in the destination table. Let me run this. Okay, now that we started the stream, let's take a look at the data. Here's my data. You can see that we have extracted all the subfields from that JSON. Okay, now let's talk about aggregation. So my next cell applies aggregations to get number of cars based on grouped by car make field. So I am reading from car traffic silver table and applying group by command, and then I use aggregate function, and I say use count my rows, and then I rename results as a car count column. The rest is just straightforward. As you can see, this is another set of commands that are very similar to batching. So I'm going to run this. One thing to notice that I am using complete mode when writing the destination. As I mentioned in the previous demo, there are a few write modes. Default types is append, which we have been using so far. Complete mode is good when you are writing only subset of your rows. So with this option, you completely wipe out your destination table and it's being refreshed every time. All right, let's take a look at the data. All right, so now that we know how to apply simple streaming transformations, let's move on to more advanced streaming topics. So the transformations that we have looked so far were treating underlying data as a static data. So in the examples that we just considered, we have calculated total number of vehicles during entire stream duration. In many cases, however, it's important to bring time dimension to your processing logic. So for example, instead of asking total number of vehicles for entire duration, you might want to divide your timeline into smaller time periods and get the aggregations for each period. So let's talk about window transformations in more details. So with window transformations, your entire timeline is divided into multiple windows, and your transformation is applied within each window. So in these examples that I brought from Databricks websites, we have timelines here. So there's events happening within this timeline, and the entire timeline is divided into 10 minutes length window. So here, for example, the time between 12 and 12:10 is one window, 12:05 and 12:15 is another window. So for window transformation, it's important to know length of transformation, length of window, of course. And the second important parameter is frequency. So in this example, we see that this window starts every 5 minutes, right? So it starts 5 minutes, 12:05, 12:10, and the length of 10 minutes. In other words, these windows are overlapping windows, but it could be sequential windows as well, which we'll see in shortly. Okay, here's another diagram that I brought from Databricks. Here we have different types of windows. So very simple and easy to understand window type is tumbling window, where your window's length is the same as its window's sequence. For example, the window here is 5 minutes length, and it occurs every 5 minutes. Another option is sliding windows, with example of which we have seen in the previous slide. So here we have this window of length of 10 minutes. However, it starts every 5 minutes. So you can see it starts 12:05, 12:10, so on, so on. So this is sliding window. So one thing to note is that tumbling and sliding windows are not dependent on events. So you are talking about fixed duration and frequency, and within this periods you may or may not have events. The last type of windows that is described at the bottom is event aware window. So in this case, these windows will start whenever your first event starts, and it will have fixed duration. So we say so in this case we say gap duration is 5 minutes. So it will wait 5 minutes, and whatever events are collected within those 5 minutes, transformation will be applied to them. And then you may have some idle time without any windows until your next events happen. Okay, let's go back to our notebook and see how window-based transformation can be applied in PySpark. So my next transformations reads from silver table and writes into gold table. It applies transformations that you can see here, which is very similar to what we have seen. So it counts number of cars. However, the grouping is slightly different. So you can see the first column is make, just like with the previous case. However, as a second argument, we are providing window. So the window function receives three arguments. The first argument is column on which you want to divide your timeline. So in this case, it's entry time. Second argument is duration or length of the window. And the third argument is frequency. Okay, so let's run this. Okay, so my stream is running, and now let me inspect my data. So my select statement is little different. So in addition to the columns that make and the car count columns that I am expecting from this output, I would also expect a window column. So this query will produce window column, which will be complex type. So it will be two parts column, and to get its start date, Windows start date, I have to provide start keyword, and accordingly to get end part, I'll provide end. So let me run this. Okay, now we can see how many cars has passed during each window timing. So as you can see, each window has exactly 6-second length. If you compare start timing between different rows, you will see that we have difference of 3 seconds. So this is apparently sliding window scenario. When you are building real-time streaming pipelines, it's important to account for possible delays in the data. So these delays may come for a variety of reasons, including connection issues or device availability issues, and your transformation logic should be able to properly handle these scenarios. So if we take examples that we previously discussed, we have windows that are closed every 5 minutes and sent down the road. So if we have events that, let's say, happened at 12:04, but have been received at 12:11, then this window will be included in the next slot or next window by default. So how do we make sure that these events are included in its correct window? To address this kind of situation, there is a watermarking concept. With watermarking function, you get flexibility of specifying a kind of grace period. So you basically can say, wait X number of seconds or minutes before you close the window. Let's take a look at the code that has watermarking logic. So my next transformation is very similar to window transformation we just looked at. However, it includes watermarking clause. With watermarking function, you have to specify fields that watermarking is based on, and then you specify that grace period. So how much time to wait before wrapping up the window. All right, now let's move on to another set of common transformations, which is join transformations. So the join transformation requires two data sources, and you have to consider different scenarios. In a simple scenarios, you need to join streaming data against static data. For example, you may have real-time data coming from devices, which you want to join against static data to enrich that data. Join between static and streaming data frames is very similar to join between two static data frames. So that's something I described in past videos. I'm not going to stay much on that. Let's talk about more interesting scenario where you are joining two streaming data frames. Just like with aggregations, when you are joining two streaming data frames, you have to account for possible delays. As I mentioned earlier, streaming is nothing but micro batches. So let's say in a given micro batch, you have rows from one data stream, but corresponding keys from another data stream did not arrive yet. So if you do not have watermarking logic in your transformations, you may miss corresponding rows because it may just arrive just after this closing of this current window. To address this, we can include watermarking transformations. So in the next cell of my notebook, I am demonstrating joining between two streaming data frames. So my first data frame is just ordinary data frame, except I assigned alias here so that it will be easier to refer to this table. And for second data frame, I attached with watermarking function. And with that, I am allocating 3 seconds delay. And here's my join condition, join transformation. So the joining conditions is based on primary key and the timestamp column. And for timestamp, I use comparison, and where I also include interval-based condition. I should mention that watermarking function is optional when you're doing inner join like this. However, when you have outer joins, then you have to include watermarking function. So the rest of my transformations is straightforward. So once I joined, I use select export method to bring necessary columns from both tables, and I write into the destination. Okay, so let's take a look at the resulting data. All right, now that we covered common transformations, let's move on to another big topic, which is triggers. As I mentioned earlier, Spark streaming uses micro batches under the hood, and by default, these micro batches are 500 milliseconds. However, streaming allows to change this frequency. So in my next cell, I have included trigger function, and with that I included interval on which this macro batches should start. So your interval can be based on seconds or hours or some other time intervals. If I run this streaming, the results will be deposited to Silver 5 table, and here's how my data will look like. Unfortunately, my data is too small to show differences in timestamps. So let's talk about another command that allows you to control your streaming behavior. So up to this point, whenever I run streaming commands, it ended immediately, even though streaming behind the scene were continuing for some time. So you can call it asynchronous behavior. However, in some cases, you may want to wait until all the available data for streaming completes, so all the streaming processing completes before you move on further. So in these scenarios, you can use await termination command, which will block your execution until streaming is done. Another helpful option to control trigger behavior is called availableNow. So with this option, streaming will stop as soon as all the available data have been processed. So that means that if you expect more data at some time in future, you will need to rerun. So this option is more in line with batch processing and could be suitable for cases where you are not expecting continuous data streams. So I mentioned lots of similarities between streaming and the batch transformations. However, there are some limitations. Some transformations are not supported for streaming data frames. For example, pivoting transformation is not available in streaming data frames. So to address this kind of scenarios, forEachBatch could be a good tool. So to use that, you have to define function. So as you can see here, I have defined Python function. This function should have two arguments. The first argument is going to be data frame, and it's going to come from your parent data frame. And second argument represents your batch ID. So this function will be called on each micro batch processing, and each function call will include corresponding batch ID, which you may use inside your function. So in this example, I am using pivoting transformation. So I group by state, and I pivot by make, so car make, and I calculate total amount. And then I save the result in car traffic pivoted table. So here's how to refer to that function. So all you need is just to add forEachBatch function and include the function here. So, and include the function name here. So let me run these two commands. And let's take a look at the data. Here's how my pivoted data looks like. So I have each car make pivoted on its separate column. Okay, so before you wrap up, don't forget to stop all your streams because it may incur the charges. All right, that concludes today's discussion. To summarize, we explored different PySpark transformations that are applicable for structured streaming in Microsoft Fabric. We also explored different types of triggers and the ways to control streaming behavior. Thanks for watching, and I will see you in the next video.